Imagine you are trying to solve a puzzle. There is food inside a container, but you cannot reach it with your hand. A stick is lying nearby. You pick it up, change the angle, and pull the food toward you. Simple. But now imagine watching a chimpanzee face the same problem. It studies the container, it picks up the stick, then it solves the puzzle. Today, we know chimpanzees can use tools, learn from one another, and solve surprisingly difficult problems. But for much of modern history, humans treated abilities like these as uniquely human. And the deeper we look into the past, the stranger that assumption becomes. Because chimpanzees have probably been using intelligence, tools, and learned traditions for far longer than we once realized. The problem is that most of their history has disappeared. So how intelligent were ancient chimpanzees? And if they were doing sophisticated things thousands of years ago, why did it take us so long to notice? The answer begins with a major archaeological problem. Chimpanzees do not build cities. They do not write books, and many of the tools they use are made from materials that quickly decay. A stick pushed into a termite mound disappears. Leaves used like sponges rot. Branches used for probing break down. That means an enormous amount of chimpanzee behavior leaves almost nothing behind. If future archaeologists judged modern chimpanzees only from what survived underground, they would miss much of what these animals actually do. But stone is different. Stone can survive for thousands of years, and that gave scientists a rare window into the chimpanzee past. In 2007, researchers led by Julio Mercader reported something remarkable from Côte d'Ivoire in West Africa. They excavated stones from a site in Taï National Park. The stones showed patterns of damage consistent with pounding. Microscopic residues included starch from nuts. And the archaeological context indicated that chimpanzees were cracking nuts there roughly 4,300 years ago. Think about what that means. Thousands of years before the modern scientific study of chimpanzee behavior, apes in an African forest were already using stone tools. Not once, not by accident. The evidence suggests a repeated behavior. A chimpanzee places a hard nut on a surface. It raises a stone, then brings it down. Too little force and the shell remains closed. Too much force and the food can be crushed. The animal has to control the movement. And young chimpanzees are not automatically experts. They learn. That is where this story becomes much bigger than rocks. Nut cracking can involve choosing an appropriate hammer, positioning the food, and adjusting force. Young chimpanzees may spend years developing efficient technique. They watch experienced individuals. They practice. They fail. Then they improve. That begins to look remarkably familiar, because humans do the same thing when learning difficult skills: observation, practice, correction. But here is what makes chimpanzees especially interesting. Different chimpanzee communities do not all behave in exactly the same way. Some populations crack nuts with stones, others use tools to obtain insects, some perform behaviors that neighboring groups do not. The differences cannot always be explained simply by anatomy or environment. Researchers have therefore described many chimpanzee behaviors as cultural traditions. Culture does not mean chimpanzees have museums or written language. It means behavior can be socially learned and maintained within a group. And that changes how we think about ancient chimpanzees. If a tool tradition existed 4,300 years ago, then knowledge may have been passing between chimpanzees long before any human scientist was there to watch it. A young chimpanzee sees an older animal crack a nut. It approaches, it watches, eventually it tries. The older individual dies years later. But the behavior remains. Knowledge has survived the individual. That is one of the foundations of culture. And here is the fascinating part. Chimpanzee intelligence is not limited to tool use. Wild chimpanzees live in complicated social worlds. They form alliances. They compete for status. They remember relationships. An individual must keep track of who is powerful, who has supported whom, and when approaching another chimpanzee may be dangerous. Physical strength matters, but social intelligence matters too. A powerful male without allies can face serious problems. A lower-ranking individual may improve its position through relationships. The chimpanzee mind is therefore solving two worlds at once: the physical world of food and tools, and the social world of other chimpanzees. But could ancient chimpanzees plan ahead? This question is harder because planning does not fossilize. Experiments with living apes have shown that chimpanzees can sometimes select or save tools for future use. Wild behavior also demonstrates that chimpanzees can travel with tools before reaching the place where those tools will be needed. That requires more than reacting to what is directly in front of them. The animal has to connect an object now with a problem later. And this is where the boundary between human and animal intelligence becomes less comfortable. For a long time, humans tried to define ourselves through one special ability. Tool use seemed uniquely human. Then chimpanzees used tools. Culture seemed uniquely human. Then researchers documented group-specific traditions. Planning seemed like another possible boundary. Again, great apes complicated the picture. This does not mean chimpanzees think exactly like humans. They do not. Human language, cumulative technology, and large-scale cooperation reached levels unlike anything seen in chimpanzees. But evolution rarely creates abilities from nothing. Many of the building blocks of human intelligence have deeper roots, and chimpanzees matter because they are among our closest living relatives. Humans and chimpanzees share a common ancestor that lived millions of years ago. Modern chimpanzees are not our ancestors. Ancient chimpanzees were not humans waiting to evolve. Both lineages followed their own evolutionary paths. But similarities between us can help researchers ask what capacities may have existed in some form before our lineages separated. Tool use, social learning, complex relationships, these abilities may have very deep evolutionary foundations. But there is another mystery. If chimpanzees were using stone tools thousands of years ago, why is their archaeological record so small? Because archaeology is biased toward things that survive. Imagine a chimpanzee 10,000 years ago using a branch to collect insects. The branch rots. Another folds leaves to hold water. The leaves disappear. Another uses vegetation as a probe. Again, almost nothing remains. Entire traditions can vanish without leaving a recognizable archaeological trace. Stone tools are different. They survive. And that means the chimpanzee archaeological record may show only a tiny fraction of ancient behavior. We may be seeing the few activities lucky enough to leave durable evidence. This has helped create a relatively new field, sometimes called primate archaeology. Researchers apply archaeological methods to tool-using primates, including chimpanzees. Instead of asking only what apes do today, scientists can begin asking a different question. What were they doing before we arrived to observe them? That question changes the timeline. A chimpanzee cracking nuts today may be participating in a tradition far older than itself. The exact age of individual traditions is difficult to establish, but archaeological evidence proves that at least some chimpanzee stone tool behavior has genuine history. And that raises an even more surprising possibility. Chimpanzee technology can change. Different tools work better for different problems. Different communities develop distinct behaviors. Skills can be maintained through social learning. That is not human civilization. But it is also not mindless instinct. It exists somewhere between, and understanding that middle ground helps us understand ourselves. Imagine our own ancestors millions of years ago. They did not suddenly wake up one morning with language, advanced tools, and complex culture. Human intelligence emerged gradually. Abilities accumulated. Old capacities were modified. New ones appeared. The difference between a chimpanzee using a stone and a human building a spacecraft is enormous. But evolution is interested in the steps between those 2 points. And living apes preserve clues to some of those steps. Not because chimpanzees are frozen in the past, but because they show what another intelligent ape can do without becoming human. And here is where the story becomes surprisingly modern. We often measure intelligence through things chimpanzees never evolved to care about. Written tests, numbers, human language. But place a chimpanzee inside its own world and different abilities become important. Remember dozens of relationships. Recognize useful materials. Learn local survival techniques. Intelligence is shaped by the problems an animal needs to solve. A chimpanzee does not need to understand algebra. It needs to understand its forest. And sometimes it does that remarkably well. There is also a lesson here about culture. Humans often imagine culture beginning with cave paintings or ancient monuments, but the basic idea is much simpler. One individual knows something, another learns it. The behavior survives. Chimpanzees show that this process does not belong exclusively to us. What became uniquely powerful in humans was the scale. Human knowledge became increasingly cumulative. One generation could improve a tool, another could modify it. Later generations could build on both. Eventually, information grew far beyond what one individual could invent alone. Chimpanzee traditions generally appear more limited in this cumulative expansion. And that difference may be crucial. Both species can learn socially. But humans became extraordinary at stacking innovation on top of innovation. Still, the archaeological evidence from Taï forces us to rethink the past. More than 4,000 years ago, long before scientists debated animal intelligence, chimpanzees were already striking stones against nuts in African forests. The sound would have been simple: stone, shell, crack. Then, another generation learned the technique, and another followed. The forest changed. Individuals died, the stones remained. Thousands of years later, humans dug them from the ground and finally recognized what they represented. Not human tools. Chimpanzee history. And perhaps that is the most surprising discovery. Humans are not the only living primates with an archaeological past. Chimpanzees have one too. Much of it may be invisible. Wood disappeared, leaves decayed, behaviors vanished without a trace, but a few stones survived long enough to tell us something important. Ancient chimpanzees were not simply animals reacting to the moment. They could learn, they could use tools, they could pass behaviors through communities, and those abilities existed thousands of years before we realized they were there. For centuries, humans looked at intelligence and saw a wall separating us from every other animal. The closer science looks, the more that wall begins to resemble a staircase. Humans climbed much farther, but we were not the only species standing on the first steps. Deep in an African forest, thousands of years ago, another ape picked up a stone. It understood what the stone could do. Then it brought it down, the nut opened, and a small piece of intelligence became part of history.